Hi, everyone. This is the Auto Guardian team introducing our mobile app. On our team is Sarah Lonergan, Taylor Cito, Michael Head, Addison Davis, and Jackson Cleveland. We'd like to tell you a little bit about our app. Auto Guardian is a revolutionary app that our company plans to launch that would give real-time notifications to your smartphone about the health status of your car. The app and company were created based on convenience and cost efficiency, being that all of our team members are young adults who have had experience with car issues at an inconvenient time or have had to pay astronomical prices on a service that could have been prevented. Our mission is to deliver a tool that is user-friendly and informative, and most of all, gives a sense of peace of mind to our customers. In this presentation, we're going to walk you through our our system design from start to finish, starting with the system service request and ending with the ERD.
So this is our system service request submitted by me. This request is for the development of a new system aimed at leveraging current trends in automotive technology and the Internet of Things. I've submitted this report to highlight a growing consumer demand for smart solutions that simplify and enhance vehicle maintenance and health monitoring. The urgency of this request is categorized under a new system, and while there are no immediate losses, it is crucial to address this opportunity promptly to maintain our competitive edge. The proposed system will provide real-time updates and actionable insights directly from the vehicle's onboard systems, aligning with current market trends and positioning us as a leader in automotive technology innovation. This development not only meets a clear consumer need, but also opens the door to a recurring revenue stream through subscriptions and premium features. Jackson Cleveland will be the liaison for this project, and our sponsor is Caroline Coyer. This system service request represents a strategic move to address consumer needs and enhance our market position. By developing this innovative application, we have the potential to lead in our automotive technology space and secure a significant competitive advantage.
This is our economic feasibility analysis. And so this is a 5-year plan, and we estimated that the project would originally cost $200,000. And then with our recurring cost and NPV of benefits, we figured out that we would end up with a 9.32% return on investment. And we would break even after about 2.5 years, or getting close to 2 3/4.
And then for the project scope statement, our project addresses a significant issue with current automobile notification systems, which are often and vague, leading to customers' dissatisfaction and reducing trust in vehicle reliability. Our objective is to provide users with real-time specific alerts about their vehicle health, eliminating unpleasant surprises and improving the overall health driving experience. The Auto Guardian system will deliver enhanced communication about car health and performance issues, going beyond traditional dashboard notifications. The system offers several business benefits, including enhanced customer satisfaction, increased vehicle reliability, a competitive advantage in the market, and a valuable data-driven insights. Our key deliverables include a mobile app for both iOS and Android, a hardware device to read the vehicle data, a subscription service, and comprehensive data visualizations and reports, and a backend system for data storage. We estimate this project duration to be about 2 months for development, testing, and deployment phases.
The business project plan is a report that's put together that consists of 4 different sections, and each section has its subsection. The 4 sections are introduction, system design, feasibility analysis, and management issues. The introduction goes into the project overview, which goes into the costs and assets of the project, as well as just an overall summary of what the project will look like. And then it also contains the recommendation is if our team recommends going through with this app or not. System description provides alternatives and a system description of what it will actually look like. It's going to be a plug-in device that'll read the card's health, and then it will send out notifications. The feasibility assessment was also covered by Michael as well. This will go into what we should be expecting in terms of cost and initial revenue that comes in. And then lastly, the management issues. This will cover what the team will look like as we go through making up this Auto Guardian app and the device, and the communication plan that we have, the project standards, and any other project specific topics.
So this is our list of system requirements. And so the first thing we needed it to do was have vehicle integration. So it'll have the capability to connect with any kind of vehicle to connect the data from or collect the data from the vehicle. And our app will have an in-ash dashboard that display visualizations based on statistics and just readings about the health of your car and kind of any potential fixes or maintenance you're going to need. And then thirdly, it'll have time for this, and this will allow you to schedule maintenance for any type of operations you're doing on your car. We're also going to offer a user feedback and support system so that we can make constant improvements of the app. And then lastly, we'll have reporting and analytics that will be able to generate reports based on your vehicle health and usage patterns. And you should be able to download and share these.
So this is our business process assumptions. First, users will enroll in a subscription for the Audio Guardian app and receive a car sensor. After enrollment, users will input their car's data into the app, which then records this information in the database. The sensor starts collecting data from the car, and the app creates dashboards and sends notifications if any issues are detected. Once a user purchases a subscription from General Motors, the order is processed and stored in the purchase order database. The Auto Guardian product is then delivered to the user, who inputs their personal and car data into the app. This information is stored in the respective user and car details databases. The car sensor collects data and compares it against the car details database. If discrepancies are found, alerts are sent to the user. These alerts and real-time data are used to produce visualizations in the app, helping users monitor their vehicle's health. The process begins with processing customer payments, validating them, and ensuring accurate records in the purchase order data store. Following this, the product delivery process involves receiving order details, preparing and scheduling delivery, and notifying the customer with tracking information.
This is our context diagram, which is a simplified version of the DFD. As you can see, we have our two entities here, the user and the car sensor, and you can see each of the different inputs and outputs that come from each entity.
And then this is our DFD0, and I'm not going to go through all of it because it is a lot going on, but I'll go through each of the entities and the processes. So with that being said, we have the user entity that then goes to process 1, which is the process consumer or customer payment. Then process 2, deliver product. Process 3, collect user and car information. Then moving on to process 4 is sense the data. 5, create alerts and reminders. Then 6, produce visualizations. So those are all the different processes. And then we also have on an entity of car sensor. So basically what's going on in this context, or not context, but data flow diagram is the flows go to from each entity to different processes in order to show the flow of how our system will work, and also includes the storing of data.
This is our entity relationship diagram, or ERD. Each of these tables is representing a data store that Taylor just talked about in the DFD. You can see we have the purchase order, car details, average car data, user identification, and the postal code. Each of these interacts with a table, and they are all related in some form or fashion.
And so as our team just went over, we were following the steps of the SDLC, the system development design. And based on what we've said, we feel that we have gone through phase 1, systems planning and selection, phase 2, systems analysis, and phase 3, system design. The part that we have not yet done in our project is systems implementation and operation. And under implementation and operation, that includes customers actually using the app, testing our personal testing of the app, and the overall deployment to our customers. But we appreciate you guys listening, and thank you.